So problem number 27 asks us to describe the transformation of the graph of the parent quadratic function and identify the vertex. So we have f of x equals 3 parentheses x plus 2 squared plus 1. So 27 and I think you said 29. Those two are going to be the exact same. They're going to go in the same way. Now we're referring this back to the function, our a parentheses bx minus h squared plus k. Well, the a deals with reflections across the x-axis and vertical stretch or shrink. Now we do have a 3 where a is, so that means we do have a vertical stretch of 3. Now, because the 3 is positive and it's not negative, we do not have a reflection across the x-axis. If it had been -3 or just a negative outside the parentheses, it would be a reflection across the x. Now, the 2 inside the parentheses tell me what? Right or left? Left, because it is positive, it would be to the left. And then the plus 1 would be up 1. Now, the vertex is the point h comma k. Vertex is our h comma k. Now looking at this here, what is the value of h? Because it's the number inside the parentheses, it's the 2, and its sign would be -2. And we would have plus 1. Because really inside that parentheses is the general formula is bx minus h, so it should be a negative. Since it's positive, it means it should be a negative. A negative and a negative would give us the positive. So that's the vertex. So 29 will be the exact same thing and set up the exact same way. So really when we're looking at this here, we're matching up what goes with what. How does this connect to each other? Back to the general equation. Give 29 a shot. If you still get stuck, let me know, and we can go over that. And we can especially do that tomorrow. Now, what we're starting off with is 2.2. In chapter 2.2, we're talking about the properties or characteristics of these quadratic functions. Now, the first thing we're looking at is with the vertex form and the axis of symmetry. These are two key elements or key components with quadratics. Now, because f of x equals a times x minus h plus k is vertex form, h comma k is the vertex, the axis of symmetry is going to be the vertical line x equals h. Because a quadratic is a U-shaped graph that is reflected across a line of reflection. And that line of reflection will always go through the vertex. It will go through the vertex. So x equals that h value is the line of reflection that will mirror across it. Just like when we've been seeing with the reflection across the y-axis, where x, or parentheses, negative x squared, let me write it down, is the same as x squared. This here, the reason this works out is because, again, we're reflecting it across its actual axis of symmetry. It's reflected onto itself. That's why that works, because y equals 0, or x equals 0, the y-axis, if it's not moved off of it, it reflects onto itself. Now, wherever this axis of symmetry is, any point to the left or right of it is going to be the same distance from it. It's always going to mirror across that line. Now, I actually didn't bring this up in the other 2 hours, but why do you think we consider this formula here, or call it vertex form? What's h and k? Vertex. So in this form, it gives you the vertex, so we're going to call it the vertex form. Kind of like with the equation of a line, y equals mx plus b. We call it slope intercept because it gave us the slope and the y-intercept, slope-intercept. So we'll call a lot of the equations exactly what they tell us. Now, I'll write this up here, axis of symmetry. When we look at this here, we're not going to be too much worried about the actual graphing this function, mainly because, as I've said in previous lessons, that graphing calculator that you all have out on your desk will graph it. We have utilities and tools to graph it, so the understanding of it is not as important as it used to be. So we're not going to worry too much about graphing. I'm going to graph this one so we can kind of see some of the properties of how this works. But the main thing we're going to find is the vertex, which is our h, comma, k, and our axis of symmetry, which is our x is equal to h. Now, what would the vertex of this be? So what's our h value? -3, and then k is 4. Because again, inside that parentheses, even though we do have x plus 3, we're really seeing x plus or x minus -3. It's the opposite of what we think, or x minus -3. And the plus 4 is the exact same. Now our axis of symmetry would be x is equal to what? H, so it's -3. X equals -3. So if we were to graph this, -3, 4, well, that there would be the vertex. And our axis of symmetry would actually just be that line, going straight up and down through the vertex. Now, I'm going to erase this here. Y'all don't have to write this down, but I'm just going to work this through so that we can see it. So I'm going to pick the point -2. Well, if I want to find the y value when x is -2, we can just plug it back in. So we can say -2 parentheses -2 plus 3 squared plus 4. And really at this point, if I wanted to, I could just type this all into the calculator, hit enter, and it would tell me what this is. Now, -2 plus 3 is 1. What is 1 squared? Well, 1 times -2 is -2, because 1 times 1 would just give me 1. 1 times -2 is just -2. And -2 plus 4 is 2. So if we were to graph this, one of the points we could use is -2, 2. -2, 2. Now, as we said, everything, the parabola is going to be mirrored across that axis of symmetry, yes? How many points have I calculated for? 1, right? Well, I know that the distance from here to here is going to be the same on either side. So it means I actually have another point right there. So if I tried, say, -4, and we'll work this out. So -2 times -4 plus 3 squared plus 4. Well, -4 plus 3 is -1 squared. So this is almost the same as the one we just did, except we had 1 instead of -1, yes? Well, what's -1 times -1? +1. Times -2 is still -2 plus 4, which is 2. So -4, comma 2. We get the same y value. They will mirror each other for the y values. So if I wanted to do this the same thing for -1, we could. So I can say -2 parentheses -1 plus 3 squared plus 4. Well, negative 1 plus 3 is going to be 2. Well, 2 squared is 4. Negative 2 times 4 would be negative 8. And negative 8 plus 4 is negative 4. So negative 1, negative 4. Distance of 2 over, distance of 2 over. Here's our other point. And that would give us an idea of what the parabola is. Because without the axis of symmetry, we actually have to graph 5 points. To get a good understanding of how a parabola looks, you need 5 points. One of them is going to be the vertex, because I need the center of it, and then we go 2 to either side. But if I know what the axis of symmetry is, I don't need to find all 5, because one will be the vertex, 2 to the left, 2 to the right. But if I know exactly what the axis of symmetry does, well, heck, if I get the vertex from the equation, 2 to the right, well, the 2 to the right also give me the 2 to the, I already have all 5. Which, that's not that bad, but again, the graphing calculator is that much faster to just plug it in. But even though I was going at a decent pace, and I could probably, if we did this enough, y'all could get going at a decent pace through this, you still would not be able to go fast enough through 2 different calculations for the 2 points, either left or right, than you could if you'd have just typed this in the graphing calculator and hit graph and had it tell you it for you. It's still going to be faster. So any questions on vertex or axis of symmetry on how we found those? Okay, let's look at the next one. Vertex. Comma K. Axis of symmetry. So looking at this equation here, what would the vertex be? Negative 4 and negative 2. Negative 4 and negative 2. And the axis of symmetry would be x is equal to negative 4. And that's it. Now, Trey, that's a good question. Why is this important? Especially the vertex and what we'll cover later with opening. The reason that this is helpful is it's giving you an idea of how the function works. The biggest thing with graphs is if you have an understanding of how it works, when we actually delve into solving, trying to find out what value of x will make this function equal 0, we have an idea of what it should do or how it should behave. That way we can anticipate what the value should be if it's going to actually have values. It gives us an idea. And really, after we get done with this, that's about all we'll need. Let's look at the next one. Vertex, h comma k. Axis of symmetry, x is equal to h. And if y'all want to do a of s, that is perfectly fine. Because especially on the homework assignments, you're probably going to get tired of writing axis of symmetry all the way out every single time. So I just put a of s, axis of symmetry. So what is our vertex? Negative 1 comma 0, because we don't have anything added or subtracted to the end. So it's 0. That's the only number that we can add or subtract and not change anything. And x would be? X is equal to negative 1 for the axis of symmetry. And that's it. That's all we have to do for this here. Any questions on this here? Well, this one here, we really don't need the graphing calculators to figure this out because the vertex would be and positive 5, yes. Now, because the 2 is negative inside the parentheses, it's going to come out as positive. Now, all the ones we've done up to this point, they've all been positive inside, so they came out negative. Axis of symmetry, x is equal to 2. And if you're not sure on some of these, you can always plug it into the calculator and see, is the lowest point of the graph or the highest point of the graph at 2, 5? If it is, then we got the correct vertex, and x is equal to whatever its x value is. And that's it. Questions on this here? Okay. Now, what this is showing us here, this next piece, is that we can really multiply that out. The x minus h squared, so we can multiply it by itself and rewrite it down. Now, what this ends up giving us is what they call standard form. The standard form, y equals ax squared plus bx plus c. And they'll sometimes call it f of x, y or f of x, either one is the same thing. In standard form. Now, I'm not going to stay on here long enough for you to write them down, but if you want to get them down, they are in the textbook in chapter 2.2. But really, A, B, and C do reflect back to H and K. Now, if A is greater than 0, A is positive, it's going to open up. If A is negative, it's going to open down. It's going to reflect across the x-axis. If A is greater than 1, it gets narrower. It's a vertical stretch. If it's less than 1, the absolute value is less than 1. Really, we're talking about between 1 and 0. It gets wider. It's a vertical shrink, stretch and shrink. It's still dealing with A. Now, the axis of symmetry is x is equal to negative b over 2a. The vertex is negative b over 2a, comma, f of negative b over 2a. But one of the key points to this is that the h, where we had x equals h for the axis of symmetry, and the vertex is h comma k, well, the x value of the vertex is still going to be the same value that we plug in for the axis of symmetry. Those values are still the same. But because the overall equation does not just straight up give us the vertex, we have to find it. We have to do a little bit of calculations to find it. And this here is not as complicated as you might think. Now, the other piece of information they give us is that the y-intercept is at the point 0, comma, c. Well, y-intercept is just where the graph crosses the y-axis. Yes? So what is the x value at the y-axis? 0, yes? So, well, if I go up to this general form, ax squared plus bx plus c, well, a times 0 squared plus b times 0 plus c. Well, what's a times 0 squared? 0, that's 0. B times 0. What's the only thing left? C. That's kind of nice. Okay, you flip to the next page. Yeah, no, writing it down is not bad. It helps. But let's actually look at this, because once we actually start doing these, it's not going to seem as bad as you might think it is. Yes. Yes. So we're going to find the vertex. And we're going to find the axis of symmetry. X is equal to negative b over 2a. So we're going to calculate these here. I'm going to redo these note sheets and get rid of those graphs so that we have a little bit more room to work with.
How did you write that so fast?
Well, I have the. It's a little bit easier when you know what you're going to write than it is trying to copy someone else's down. B over 2a, negative b over 2a. Now in both of these here, the main thing that we have is negative b over 2a. Because if I can find out what that is, I'll have the x value of the vertex, and I'll have x equals, I'll have the axis of symmetry. I'll have both of those, if I can figure out what negative b over 2a is. Once we finish that, then we'll figure out whatever f of negative b over 2a is. Well, what is a, b, and c for this here? What do we think a is?
A is probably. No, it's
3, b is
6.
negative 6, and c is 1.
No, it's not.
Because we're looking at ax squared plus bx plus c, and it's referring back to that equation.
So 3 is 6.
Now, will the a variable ever contain x? Will it contain x squared? Well, no. A is the number in front of x squared. So it's 3. B is the number in front of x. And since it's minus 6x, the value of b is minus 6, or negative 6. And the value of c is 1. So our formula is negative b over 2a. So we could say negative what? Over 2 times 3. So we have negative 6 over 2 times 3. Can we plug that into a calculator?
Positives.
Yeah, it's all numbers. Well, we can calculate it out. Negative makes a positive. 2 times 3 is 6. And 6 divided by 6 is 1. That's it. So the x value of the vertex is 1. The axis of symmetry, x equals 1. Any questions on this so far? The negative b over 2a not as bad as you thought it was going to be? Now we know how to figure out what f of negative b over 2a is. Yes? Well, that negative b over 2a is 1, yes?
Yeah.
So really we have f of
1.
Well, that's a good question. That's actually what I was going to ask next. Well, 3 something squared minus 6 times something plus 1. This should look familiar. Here's the equation, but what did I do? I replaced x with 1. Because f of x, we're plugging it back in. F of negative b over 2a is really just saying we take whatever the x value is that we found for the vertex and plug it back in to find the y value. Because there's not an easy, like with the vertex form, where it's just a value in the function. No, we've got to plug it back in. So once we find the x value of the vertex, we plug it back into the function to see what the value of y is. Well, we could actually just type that in a calculator, 3 parentheses 1 close parentheses squared, minus 6 times 1 plus 1. What's 1 squared? 1 times 3 is 3. Okay, and just get 6 times 1 is still going to be 6. So we have 3 minus 6 plus 1. 3 minus 6 is, plus 1 is negative 2. So the y value of the vertex is negative 2. So the vertex is 1 comma negative 2. The axis of symmetry is x is equal to 1. That's it. I mean, we could find the y-intercept. And we said the x value at the y-intercept is 0, and the y value would be 1, because the value of c is 1. But really, if I plug 0 in for x, anywhere that has an x with it is going to become 0. So the only thing left is 1. Questions on this here? We're going to still look at another one. Let's look at this one here. X squared plus 2x minus 1. Well, our vertex is negative b over 2a, comma, f of negative b over 2a. We'll get the vertex. The axis of symmetry is x is equal to negative b over 2a. So this here is the next problem. We'll look at it in a minute. So the big thing that we have is the negative b over 2a. Negative. What is our value of b? 2 over 2 times a. A is 1. Because if there's not a number specifically written in front of one of the variables, it's understood to be 1. Because multiplying anything by 1 doesn't change what it is. So we don't write 1 if it's being multiplied. I can write it down below. Well, on top we'll have negative 2. 2 times 1 is 2. So negative 2 divided by 2 is negative 1. So the x value of the vertex is negative 1. X equals negative 1. So we found the x value of the vertex and the axis of symmetry. Questions on how we found either one of these here? Well, now we just need to find the y value of the vertex, yes? And to do that, we take the x value and plug it back into the function. So a negative 1 squared plus 2 times negative 1 minus 1. And again, at this point here, you can type this whole thing into the calculator and it would throw it right back out to you. So negative 1 squared is 1. 2 times negative 1 is negative 2 minus 1. Well, 1 minus 1, 0, so I'm left with negative 2. I could do 1 minus 2, which would be negative 1. Minus 1 is negative 2. So the vertex is negative 1, comma, negative 2. Questions on this here? Okay. If we're good with this here, let's look at one last one. Well, this is the last one that we'll look at before moving on to the next part. But vertex is our negative b over 2a, yes? What is our value of b? Negative 8, yes. And our value of a is negative 2. And again, we could plug this in, or negative 8 is positive 8. 2 times negative 2 is negative 4. 8 divided by negative 4 is negative. So the vertex is negative 2. The axis of symmetry is x is equal to negative 2, yes? Now I did this so that we can kind of check and see and make sure we do have the right number. Let's grab the graphing calculator. And let's see if we can get the rest of it using it. Okay, watch out. So we're going to start off with hitting y equals after you get it turned on. And what we can do at this point is plug the equation in. So negative 2x squared minus 8x the square. So this button here, the x, t, theta, n, will do x for us. And then I think it is, was it plus 2 at the end? Plus 1. I haven't said this at any point, but if you do notice press key history, it does log what I press. So down here. So if you're ever rewatching it, it will tell you the key history. Now, once you get this typed in, go on and hit graph. Once you get the whole thing typed in, go on and hit graph. Any questions so far? We all got it typed in? Yes? So we get this here, yes? And we said the x value of the vertex was at negative 2. So at negative 2, that is kind of where the top point is, isn't it? Okay, so we could actually use the calculator to figure this out. One way could be just typing negative 2 into the function. Or if I type the function in, if you go second graph, when x is negative 2, what's the value of y? 9. There's the vertex. Because we also said something else about the vertex and the axis of symmetry. Well, the axis of symmetry, every point to the left and right is mirrored. What's the y value? 1 spot above and 1 spot below 9. It is 7. We have 7 above and below, don't we? Well, above that, we've got 1 and 1. Then negative 9 and negative 9, negative 23, negative 23, negative 41 and negative 41. Those values mirror. And they should, because that x equals negative 2 is the axis of symmetry. They should all reflect across this line. Questions on this here? So let's see another interesting tool. Go second trace. Second trace. So go on and click second trace. So you get a list like this here that says calculate. Let's say value. So go on and just hit enter. And you should get this here. It gives you the graph back, and it has x equals and has little block flashing. But we know the x value of the vertex is at negative 2. So if I type that in and say x equals negative 2 and hit enter, it tells me y is equal to 9. It plugged it in and figured it out for me. Well, the table told us that also, yes? So if I go second calculate enter, so I pull it up again, because if I want to put a different value in, I have to do that again. But let's say negative 3.7958324. I just picked a random number. But that's not on, yeah, but it's not on the table because table only did whole number values, yes? I say enter. The y value for this function is 2.549972. So it plugged it in for us. So that's kind of nice. So if I have the function, and they might say that on the ACT, evaluate the following function given the value, I could type it into y equals, say second trace calculate or find value, and it'll do it for me. Questions on this here? Okay. So we found that the vertex was -2, 9. Because the calculator told us, either by the table or by just calculating the thing out. Okay. We're about right on pace. For the quadratic function, we can have one or two types, one that's going to be opening up and one that's going to be opening down. Now, one of the key features to this that I do want to point out is that the domain is all real numbers for either one. And really, any quadratic function, any higher degree polynomial function, the domain is going to be all real numbers. And what that's really saying is that any value of x, I can plug it into the function and it's going to work. The only time that really we're going to not have the domain as all real numbers is when we're talking about rational functions, where the variable is in the bottom of a fraction, or radicals, so square roots, cubed roots. If it's inside a square root or cubed root, really any even degree root, then it won't be all real numbers. And we'll cover that later in the year. Now, looking at the one that's opening up, if I picked any point along this function as it goes up, will I be able to find a point that's bigger than whatever point I picked? Yes, because those lines extend indefinitely, yes? So will this ever have a maximum value? No, because whatever I pick as the maximum value, there's still going to be a point slightly bigger than it. But this point right here, is there any point lower than it? No. So whenever the parabola opens up, it will have a minimum value. And we'll talk about and we'll think about the minimum value according to the y going up and down. What is the minimum value? The y value. And the range, well, since it's opening up, all the y values that are greater than whatever the y value of the vertex is would be the range. And we'll look at decreasing and increasing as we actually look at the graph. It'll make more sense when we see it. The maximum value, well, kind of going down because it's opening down. There will always be a point lower on the graph than whatever point I choose because it's opening down. So it means the vertex is going to be the biggest value, the biggest spot on the graph, because all other points are less than it. All other points are going to be less than it. And the range is going to be all the y values less than whatever the y value of the vertex is. And again, when we start looking at the graph, the increasing and decreasing is going to make more sense. All right? Well, I